In this section, I'm often gonna compare two plugins because I think that they're different in layout and the way they work can teach us a lot about granulation. So those plugins are Faceplant, which has a granular module, and Padshop, which is the granular sampler that comes with Cubase. But you can buy it separately, and honestly, it's a very good plugin. So first of all, I think one of the most common uses of granulation, at least when it comes to sound effect design, is the kind of like randomized cloud of grains pad. Like, for example, if I choose a sample that has like a lot of movement from one moment to the next, it's not gonna be the best example to create a pad, but just for the sake of the example, like this one. Okay, let me. If the playback position is in that zone, I hear only that texture, but in that zone, I hear kind of the other texture. And then if I randomize the position, maybe I can randomize the pan too. You get kind of a randomized blend of the sample. And with a more stable sample, you can make a pretty convincing pad. If you want a thicker, less defined pad, you can, of course, add more grains. And then you can randomize their timing, their pitch. You can reverse some of those, maybe like half. It's gonna be more obvious with another sample, I think. Like, only forward with some reverse. Like, I guess this one is cool, maybe we can print it. And then, of course, we can make a riser out of it. Actually. So same as before, an envelope on the volume, an LFO on the pitch. Maybe I want just a little bit of distortion on that. I guess this is a decent riser. And of course, then we can just kind of like have a look at other samples. But this is not the only use of granulation. And with a lower grain count, like even just one grain and a more defined approach, you can make very interesting sounds. Allow me to demonstrate. So, by default, Padshop granulates a sample of a sine wave, and that can sound boring, but that's very instructive. So if I just play the init patch, it just sounds like a sine wave with a tremolo, right? And actually, we can probably reproduce that effect. Like sine wave, disable that one, way lower. Roughly the same sound, right? And then, of course, if we have a higher frequency for the modulator, you start hearing the kind of ring modulation harmonic content being added. So what happens with Padshop if we have a smaller grain duration? Pretty much the same thing, right? And the explanation is very simple. If you look at the grain shapes available in Padshop, you see that a few of them kind of look like a sine wave, right? Those are called window functions, and they're essentially envelopes applied at the scope of each individual grain. So now let's use a sine wave as our source signal, like in Padshop. For simplicity's sake, let's assume that we're using the actual top half of a sine wave as our window function or envelope. Let's also assume that we're triggering the grains in a synchronous manner, that we're only having one simultaneous grain, and that our trigger rate for successive grains corresponds to the duration of a single grain. If we zoom into the process of granulation, grain per grain, this is the grain's envelope, this is the output, and then the next grain, and the next, and so on and so forth. Doesn't it look like we're essentially doing ring modulation where the carrier is a sine wave and the modulator is kind of the upper half of a sine wave? And actually, let's graph just that to compare, and it's pretty much the same. By the way, the process of mirroring the bottom half of a signal is called rectifying, and you can do that natively on the modulating oscillator inside of the ring mod module. And then some of these grain shapes look more like triangle waves, and the same goes for faceplant if you draw a grain envelope that looks just like this. So again, if we zoom in on the waveform, we're essentially doing ring modulation again. But this time the modulator is a triangle wave. So for all intents and purposes, when you're doing granulation, you're applying some form of ring modulation. So I've exported all the sounds we made earlier as kind of a new folder of building blocks. So what if we load, for example, this whoosh? Okay, up. All right, not very interesting. Let me again create a volume envelope and then maybe have it like this. Set it to one shot. Duplicate it, and this one could be a pitch envelope later. And then all right, and then this one would drive the volume. So one thing we're missing is the kind of the playback of the original sample. And in order to do so, you just create a new LFO. And for now, let's just have like kind of a straight line. And that LFO can drive the playback position of the grains. And then we can play with the envelope duration. you can really quickly create very interesting articulations. So I'm gonna save that one. And then maybe we can select another sample. And then, of course, you could use that LFO to add another layer of pitch modulation on top of the one that's already present in the sample. Gonna modulate here. All right, and that effect you just heard when I introduce a higher grain count, this kind of like phasey, flangy effect is actually one of my favorite things with granulation. And allow me to switch back to Padshop to demonstrate this. So we have our kind of like tremolo sine wave. What happens if we add more grains? Right now, the second voice of grains is simply kind of filling the void between two consecutive grains. One thing that you can notice with Padshop is that it has a speed parameter, and that's because by default, it's doing the kind of like playback scan for you. Like the grain playback position is moving at a rate that is quote unquote the correct rate to kind of like playback the sample at its original pitch. But what happens if we lower that speed? And shorter grains, higher grain count. Some really weird stuff is happening, and that's because of phase. So again, let's assume we're granulating a sine wave. These are all consecutive grains. And now we're changing the grain playback position speed. If we zoom in on the grains now, this is one grain, this is the next grain, and this is the resulting output. What happens if we introduce some overlap in the grain content by lowering the grain playback position speed? You can see in the output waveform a mix of phase reinforcements and phase cancellations. So in essence, granulation is introducing some comb filtering, same as with the flanger. For example, if we load one of the hits we made, like I guess this one is fine. So again, okay, let me disable the loop. So this is just sounding kind of like our sample, right? But if we drop that speed, or the opposite, if we have a higher speed, you can create all kinds of weird tones just by playing around with the speed, the duration of the grains, the number of grains. Like, I kind of like this one, honestly. So And you can have the same effect with faceplant. Okay, let me switch to a hit for now. Okay, so right now I have kind of a whoosh, but let me disable that and... Like, this one sounds good. And one interesting thing is just by changing the rate of the... Like, let me for now kind of decouple the rate of the position LFO so I can just like move it freely. Then I can scan further. Like, this one is not an interesting... Yeah, honestly, that's one of my favorite ways to create that kind of like phasey, flangy, sci-fi type of tone and texture that kind of sounds like a flanger, but not really, like less obvious, less boring maybe. Okay, let's try with another sample, like this one maybe. Yeah, this one is fat. The same can be made with whooshes, like, I don't know. This one, by the way, the kind of comb filtery tone that you hear in the original sample that was already in the building block was probably obtained with granulation. This is, yeah, I just love it. This is insane. Okay, let's bring back the other LFO. I guess this one is kind of cool. Maybe we can use a hit as a source for a whoosh. Okay, let me reduce the grain count so that we come back towards more of a tremolo. And let me crank the distortion. And actually, maybe I don't wanna... Maybe I wanna stay in the same zone. You know what we're missing? We're missing some reverb. Yes. Okay, I guess this one is cool. Okay, this one is really fun. It sounds kind of cartoonish. So this one is cool. Okay, I really like this one. And then back into that kind of tremolo range I was talking about before. I think I like this one too. Actually, maybe we can scan backwards. Kinda like it. And then on top of that, we can have reverse grains. One other thing with granulation in faceplant is that by default it's on density mode, but you can force a rhythm or a pitch. The pitch is expressed in hertz, so let me for now disable the pitch shifting. So this means that currently it's triggering 10 grains per second. Okay, of course. I kind of liked this one. And then instead of modulating the master pitch, you can modulate that trigger rate value with that LFO. Okay. It kind of sounds like a resonator, like a metallic type of sound. Of course, you can also modulate the pitch. Like, this is not the pitch of the grains, It's the rate at which the grains are triggered. But this is the pitch at which each grain is being played back. So you've got two parameters having a separate effect on the tone and the pitch of the sound. I mean, this one is nice. Okay, I really like that one. Okay, let's try with a different sample. Okay, I really like that one. I mean... this is nice. You've got that very complex interaction between the pitch of the original sample that is going up, but then you've got the grain playback pitch that is going down, and then you've also got the grain trigger rate that is going down. But it's just so complex and like impossible to sort of master all of the parameters. But by just like randomly turning the knobs and just like fine-tuning, you'll fall on like sweet spots, on like happy accidents that are cool. Like, right now we're scanning fast enough that the upwards pitch movement of the original sample is kind of taking over. But if we reduce the range of modulation from that LFO, it's less the case now. Like 7 Hz, we're under 20 Hz, we're not in pitch territory anymore. It's becoming a rhythm. By the way, this is a very useful tool for risers too. Like, let's go back to one of our riser patches. What if, instead of modulating the pitch of the patch, we switch to Hertz mode for the grain trigger rate? This is because, yeah, the position is too random. And then maybe we can have an LFO that scans the samples. You know what? Actually, we kind of... maybe we can loop that one. Like, maybe we can have a faster rate go... and then... okay, let me just like remove some of that sample so that we have like more precision, and then... yeah, I know. Maybe actually... I know, I have an idea. So we already have some kind of a riser because we're playing a part of the sample that gets richer and richer over time. But then maybe we can also take that LFO and modulate the grain trigger rate. Yeah, of course, the end of the riser is gonna be weird because this LFO stops and this LFO stops, but I think we have something kind of interesting. And then maybe we can also modulate the pitch? Like... Yeah, I guess.